In this video, we're going to be doing some Unit 6 torque practice. So, a force of 10 newtons is applied to a 0.5 meter lever arm at an angle of 90 degrees. What torque is produced? So, torque is equal to Fr sine of theta. So, you just plug in your values. You have 0.5 times 10 times sine of 90 degrees. Sine of 90 is equal to 1, so that's going to be 0.50 times 10 times 1, that's going to be 5.0 newtons times meters. A 4-meter uniform beam is pivoted at its center. A 20 newton force is applied at one end perpendicular to the beam. What is the torque about the pivot? So, if it's pivoted about its center, that means the pivot is going to be at 2 meters, and this entire length is 4 meters. So our lever arm is going to be equal to 2 meters because it's at one end of the perpendicular beam. This is going to be 90 degrees, which is theta. So now in torque is equal to Fr sine of theta. You're going to have Fr sine of 90, and sine of 90 is equal to 1. So you just plug in your F and R. So that's going to be 2 times 20, which is going to be 40 newtons times meters, which is option C. A force of 15 newtons acts at 30 degrees to a 0.4 meter lever arm. What is the torque? Torque is equal to Fr sine of theta. So you're just going to plug in your values. We can also draw this out. This is going to be our figure. So we have a force that is 15 newtons to 40. So this is going to be 0.4 meters of a lever arm, and let's say that this is our pivot. So that's our distance from the pivot. This is going to be equal to this is equal to 30 degrees, and this force is equal to 15 newtons. So that's going to be 0.40 times 15 times sine of 30 degrees. That's going to equal to 3.0 newtons times meters, which is option B. A seesaw is balanced with a 30 kilogram child 2 meters from the pivot. Where must the 20 kilogram child sit to balance? So this is a situation where you have rotational equilibrium. Now let's draw out a diagram of this problem. So on the left side, you're going to have a pivot, and the pivot's going to be in the center, because usually when you have a seesaw, it's going to be in the center. So there's a 30 kilogram child that's 2 meters. Say that this is 2 meters. So there's going to be a child here. And we also have to have another child that is 20 kilograms, but it's going to be somewhere else. How do we figure out where? So when you have rotational equilibrium, your net torque is going to be equal to 0. And you have the summation of your torques, which is going to be the left torque plus the right torque, which is equal to 0. And then you just subtract your left minus your to both sides. And then you just isolate your right. So then you can see that your right torque is equal to your left torque. And you can break down your torque into what it is. So torque is equal to the force times R times sine of theta. Your force is just going to be the weight. Force is going to be your weight force, and your weight is equal to mg because it's equal to fg. So it's going to be sine of 90. Sine of 90 is going to be equal to 1. So that means that it's going to be weight times R times 1. So now you can take your torque and you can substitute it in here. So you can replace your torques on both sides with these. You can rewrite this as m1 times gravity. Actually, let's write that here too. So torque is equal to mg times r. So let's write this out for both our torques. So we have m1 g r1. Because the things that are different are going to be the masses and also the radii. So, and on the left, you have M2, R2. let's actually just switch the directions of this. Say left is here and right is on this side so that it looks nicer. And I'm going to make this on the left hand M1, and this is going to be radius 1, this is going to be M2, and then this is going to be radius 2, which is going to be a mystery for now. You just plug in your values, so you're going to have 30 times 2 is equal to 20 times r, so you get 60 is equal to 20r, and you divide both sides by 20. R is just equal to 3 meters, so that's just going to be C. A wrench applies a force at an angle that's less than 90 degrees. How does torque compare to the maximum possible torque? So your force is going to be applied at an angle that is going to be less than 90 degrees. Torque is equal to Fr sine of theta. We know that when you have your maximum torque, it's going to equal to when you have your theta is equal to 90 degrees, because sine of 90 is equal to 1, and you're always going to be multiplying this component, the sine theta part, times your Fr. So it's going to range from, we know that sine's range is going to be from -1 to 1. So if you multiplied your Fr by -1, that would be a negative torque, and the largest you could ever have is going to be 1, and everything in between that is going to be a decimal. So 1 would be the largest torque that you could ever exert. So 90 degrees is kind of going to be your goal for max torque. So if it's less than 90 degrees, that means your torque is going to be less than your maximum. Now, a beam is in rotational equilibrium. Which of the following is true? So when you have rotational equilibrium, the summation of your torque is equal to 0. Rotational equilibrium does not equal to no motion. You can still have motion. You just have no rotational acceleration. You can still have translational motion, because this is talking about rotational equilibrium, not translational equilibrium. So that means your net torque is equal to 0, which is C. A 2 kilogram mass hangs 1.5 meters from a pivot. What torque does gravity exert? So it doesn't specify where a pivot is, so we're just going to say that it's going to be 1.5 meters is equal to R. And right here, you have your 2 kilogram mass. We want the torque from the gravity, so we know that Fg is equal to mg. So we know that F is equal to mg, so you can 2 times 10, or we'll say 9.8 meters per second squared, and that's going to be approximately 20 newtons because it's basically 10. Now your torque is equal to Fr sine of theta. We know that this angle is going to be 90 degrees because the force is going to be vertical, the lever arm is going to be horizontal, and that's 90, so that's equal to your force of 20 newtons times your lever arm of 1.5 times sine of 90. This is equal to 30 newtons times meters. 2 forces act on opposite sides of a pivot at equal distances but in opposite directions. What is the net torque? So we know that torque is going to be dependent on our force direction and also on your position that is relative to the pivot. So in this situation, even though our forces are going to be in opposite directions, they are still going to produce the same rotational direction. And you can see this if you have a object like this on opposite sides of a pivot. So they're equal distances. So let's say they're both at the end, but they're in opposite directions. This one's going this way and this one's going this way. If you push this way, you're gonna go in this counterclockwise direction. If you go this way, this is clockwise. And if you go this way, you're still going in clockwise direction. So your net torque is going to be torque plus torque, which is going to be 2 times your torque. So it's going to be doubled. A force is applied parallel to a lever arm. What is the torque that is produced? So torque is equal to Fr sine of theta. So if you have two forces like this, we can say that the angle between them, they're just going to be like on top of each other. So that means you're going to have an angle that's equal to 0 degrees because they're going to be directly on top. So you would say that they're parallel here. So we know that Fr sine of 0 degrees on your unit circle, when you're at 0 degrees, you are at a height of 0. You're going to be at 1, 0. So you're looking at your y, you're at 0. So that's going to be Fr times 0, so that's equal to 0. A 5 Newton force acts at 0.2 meters at 60 degrees. What torque is produced? So torque is equal to Fr sine of theta. So you have a force of 5 newtons and a lever arm of 0.20 meters and sine of 60 degrees. Sine of 60 degrees is equal to root 3 over 2. So this is 5 times 0.20. This is going to be approximately 1, and this is going to be equal to 0.866 newtons times meters approximately. So we'd say B.